Here's a solution to one of the problems that's on the online homework for section 2.5, and this was also on the worksheet for the same section that we did in class, and this is really exactly the same problem with just different numbers. But the video I did before on the worksheet did not include this one since we did one in class, but I have had some questions about it, so here's a video to so you can see how it works and whenever you're ready to look at it. So here we're given a price-demand equation, which means that we're told the relationship between the price we charge for the whatever these are, suits. So the price we charge for the suits and the number of the suits that we can expect to sell. And so this is this idea of supply and demand in economics, that if you make something cheaper, you expect to sell more of them. Anyway, so this is the equation that relates price and the number we expect to sell. And then everything else we can do based on that. The first question is find the total revenue. So revenue is just the price we sell something for times the number we expect to sell. And so X here is the number we're selling, right? X suits. And the price that we expect to sell those suits for is given by the price demand function. So 150 minus 0.75x. So again, this is just this idea that revenue is number you sell times the price you charge. And so we can write that as a function of a single variable. And I might as well multiply that out because I know I'm going to have to do some calculus here at some point. And so eventually I'll be happy that it's multiplied out. So that's 150x minus 0.75x squared. The total profit is, we know profit is revenue minus cost, so revenue is 150x minus 0.75x squared. That's our answer to part A. So that's supposed to be a squared. And subtract cost, and cost is 3,500 plus 0.75x squared. Don't forget the parentheses. When you say revenue minus cost, you mean the entire revenue function minus the entire cost function. So if you don't put parentheses around those things, then you're not really subtracting the entire revenue, the entire cost from the entire revenue. And again, I should simplify that. I'll write that down here. It's too hard to squeeze in up there. So there is a little bit of stuff that I can combine. Notably, this 0.75x squared and this 0.75x squared can be combined. So I'll have 150x minus 1.5x squared. That's 0.75 plus 0.75 minus 3,500. So that's my profit function. That's the answer to B. It's multiplied out and simplified so that I'm ready to do my calculus part. So for part C, it says how many suits must the company produce to maximize, there's our optimization word, profit. So that means that we need a function whose outputs are profit. That's what B got for us, so they have led us to that already. And so I go into my routine of finding critical values. So P prime of x is 150 minus 3x. I know this is a downward shaped parabola, so maximizing it is really just finding that one critical value. So as long as that critical value makes sense, as long as it's a valid value of x, then it doesn't really make any difference what part of the parabola you look at. So anyway, so we don't have to really worry about endpoints of intervals here because it's just a parabola. Anyway, so this is 0 when x is 50, and 50 does seem like a valid value of number of suits. If you go back and check, that makes your price a reasonable amount. Makes your suits $100 and some. So there's nothing wrong with that as a value of x. So that's going to be our answer to part C, because it wants to know how many suits. Remember, x represents the number of suits. So when you say x equals 50, you mean 50 suits. That's what x stands for. So that is in fact the answer to part C. What is the maximum profit? Well, we found the maximum profit happens when you sell 50 suits, but the profit when you sell 50 suits is given by this formula, right? In this formula, P of x, the inputs are the number of suits, the outputs are profits. So we put, my calculator turned off, hang on. Okay, so when I put 50 into the profit function, I get 250, and so that's dollars. So that's my profits. My units here are dollars. So when I put 50 suits in, I make $250. So that's a pretty thin margin. What's happening there is that even though you're charging 100 some dollars per suit, and so your revenue is over $5,000, this cost function is killing you, because that cost function is growing really fast. So your cost is when you're to make 50 suits with this cost function, your cost is also in the $5,000 range. So this is not a great profit margin. Anyway, but they just make problems up. So what do you expect? What price per suit must be charged to maximize profit? Well, remember, this is the price demand equation. So if you know one of the variables there, you know the other one. The P there in that equation stands for profit. Stands for price. I was going to say that. The little p here stands for price, and so price is related to x, and x is 50. So that's going to tell us the price we ought to charge is 112. Surely I can do that. Probably not. So $112.50. So you're selling $100 suits, but somehow selling 50 of them only nets you $250 in profit. So probably you need to do something with your business. This is pretty bad, and the cost function there is just killing you. Anyway, but that's all editorial. That's how you do the problem, and I think there were a couple of like that between the online homework and the ones on the worksheet that you can try, but the process is the same.